Okay, algebra, here we go with another example of our linear functions graphic organizer. In this problem, we're going to start with a linear equation that's given in point-slope form. And the purpose of this exercise is to see all the relationships between the different forms of the linear equation, make sure we understand what we can pick out from each form, and how we can convert from one to the other, and how we can use the different ones to create the graph. So when we're looking at point-slope form, which is this, hold on, let me make that. All right, so when we're using point-slope form, which looks like this, all right, we can pick out, or what this form is actually telling us is it's given us slope. Here's our m. And we know from this number and this number, we know a point. And the x-coordinate's always paired with the x, and the y-coordinate's paired with the y. And it's opposite. All right, so now once we have this information, now we can use this to create the graph. We start with the point, which is at -3 and up 4. So there's our point. Then from that point, we use our slope information, down 2 and over 3. Now when we look at this slope, it's negative. So that means our function should be decreasing. So look at the way you put your points on the graph. When you connect them, will your line be going down? And the answer to that question is yes. Those points would form a line that's decreasing. It's going down from left to right. And I could locate several more points by going down 2 and right 3, falling 2 and running 3. Or I could go up 2 and left 3. But I'm going to run out of room. So I can locate all these different points. Remember, there's an infinite number of points on this line. I just need to locate 2 so that I can figure out the direction and where to place my line. So this graph is a picture of all the ordered pairs that make this equation true. Now I could fill in some other stuff here. I have the slope. So I can fill in this box. And now this box also asks me to identify what the y-intercept is. So we need to understand the y-intercept is where my line crosses the y-axis. It's an ordered pair that always has an x-coordinate of 0. So the y-intercept would be 0, 2. Once I have slope and y-intercept identified, I can write my equation in slope-intercept form by filling in m for slope and the value where it crosses the y-axis. I could fill in table of values. I have coordinates. I have the y-intercept, that's a coordinate. I have the coordinate from down here in point-slope form. I have some other points I located on the graph. This other point, 3, 0. I could plug some numbers in for x, do the math, and find y to complete this. Or I could look at the pattern. This pattern says that, remember, it's change in y over change in x, so if I were to add 3 to x, my y should be going down by 2. So for example, 6 would be at down 2. If I went up 3 again, I would be at -4. And you can see that those points would make sense given my line. All right, the last one that I need to write is this line in standard form. And when I'm looking at a line in standard form, x and y are together on the same side of the equation, the constant is all by itself on the other side. A and x must be integer values, in other words, no fractions, and a should be positive. So to get to standard form, I have to take one of the forms that I already have, either point slope or slope intercept, and convert it to standard form. Let's take slope intercept form and convert it to standard. So I'm going to start with what I have in slope intercept. And to get it in this form, I need to get x and y on the same side. I'm going to leave the 2 over here, and I need to get rid of any fractions. So I'm going to do the fraction part first. So to get rid of this fraction, I want to think of this 3 as a division. So to undo division, I'm going to use multiplication. So I'm going to take the whole equation and multiply it by 3 to undo that division of 3. So that'll give me 3y equals, that 3 and that 3 will make 1, so I'm left with negative 2x. 3 times the 2 will give me plus 6. So all these are equivalent. All these different linear forms are equivalent. Alright, I'm not quite in standard form. To get it in standard form, I got to move the 2x over here. So I'm going to add 2x to each side. I can't combine these, they're not like terms, so I'm just write them together with an addition sign in between. And that's a 6. That is standard form.